What if your OSPF network was silently failing and you didn't know why? In this real-world troubleshooting lab, I'll show you how to fix 6 different OSPF failures, including the sneaky IPv6 mistake that catches even experienced engineers. Want to become an OSPF troubleshooting ninja? Let's dive in. As for the practical work of troubleshooting on the EGRP, here we have 6 routers that are connected to a central router. These 6 routers all have a different problem. We will see the different troubleshooting steps. We'll start with router 2, checking what router 1 sees, with a show IP OSPF neighbor. We can clearly see router 2 as neighbors, represented with its router ID and 3 times 0.2. It is targeted at the end of the Ethernet interface, 1 or 0 of this router. Now if we do a show IP protocols, we can see that no access list is configured and that the 10.0.0 network envelopes that of router 2. Because his mask inverted of 0, 3 times 255, give it normal, 255.3 times 0. This means that the OSPF runs for all IPs, which range from 10.3 times 0 to 10.3 times 255. Before moving on to router 2, we will analyze its routing table with a show IP route. Here, we can see the 10.1.1.0 network, which corresponds to the link between router 1 and 2. On the other hand, we do not see the 192.168.2.0 network, which corresponds to the loopback of router 2. Which means that if router 1 receives a packet destined for this network that is behind router 2, well, it won't know what to do with it. Except for deleted the package. We can now go to router 2 and give it a show IP interface brief. The Ethernet interface 030 that points to router 1 is up, but the one of loopback 0 is administratively down. As for the other interfaces, they are not used. If we look at the current conf file with a show running config, we can see that in the loopback 0 configuration, there is a shutdown line. The interface has therefore been administratively cut off by a network admin. We will reassemble the interface by connecting to it with the command interface loopback 0, and we will activate the port with a no shutdown. Now, if we go back to router 1 and we do an IP route show on it, this time, the 192.168.2.0 network is indeed in its routing table. Let's move on to the router 3 problem. As we are already on the routing table of router 1, we notice that the network 192.168.3.0, which corresponds to the loopback of router 3, is not there. By launching a show IP OSPF neighbor. Note that router 3 is not part of the list of neighbors because its router ID is not found in 3 times 0.3. We will display the list of its neighbors in CDP with a show CDP neighbor. There, he can see him as a neighbor and that he can be reached on port 11. If we run a ping 10.1.1.6, which corresponds to the Ethernet port at the other end, it works properly. So, there is no problem on the IP layer, but rather a problem on OSPF routing. It's time to switch to router 3. So here, we see several error messages that are displayed on the CLI. They're about them every 10 seconds. To avoid it bothering us, we will switch to simulation mode by clicking on the bottom right of Packet Tracer. Then, mode simulation. You can now do a show IP protocols to it without being bothered by the logs. Here, we see that the OSPF area for the network that is connected to the router, the 10.3 times 0, is set to 1, while all the interfaces of router 1 run in area 0. We'll confirm this detail by going to the conf file with a show running config. The 10.3 times 0 network of the OSPF that carries the ID 100 is well configured in Area 1. That's why router 1 doesn't see router 3 as OSPF neighbors. So let's modify it in the OSPF settings by making it an OSPF 100 router and a network 10.00.2555.2555.255 area 0. You can now go back to real time by clicking on the bottom right of Packet Tracer. We can see in the logs that the area for the network 10.3 times 0 has been changed from 1 to 0, and that the neighbor relationship with router 1 has been initiated. If we go back to the ladder and throw a show IP route 192.168.3.0 to analyze the network of the loopback of router 3 again, this time we can see an entry through the OSPF routing which carries the ID 100. And if we do an OSPF route IP show, we also see the line 192.168.3.0. The AI symbol that is represented after the O in OSPF means that it belongs to a different area than that of this router. We can now move on to the problem of router 4. Here too, we notice that once again, the network of the loopback 0 of router 4 is not present. The 192.168.4.0 network is not in the route table of router 1. By doing an OSPF neighbor IP show, it also doesn't see the router that carries the ID 3 times 0, 4. To continue, we run a show CDP neighbor. We note that it can see router 4 well. With a ping of the address 10.1.1.10 corresponding to the interface of router 4 at the other end, it works very well. So it looks like another OSPF problem directly on router 4. Let's do a show IP protocols on the ladder. Here, we see the line 192.168.4.0, which wears an inverted mask, and 3 times 0.25, which has the effect of rotating OSPF, the IP range, which goes from 192.168.4.0 to 4.255. The address of the loopback 0, which is 192.168.4.1, is part of this IP range and therefore participates in OSPF routing. Then we see the line 10.1.1.0 with an inverted mask in 3 times 0.3. This means that the routing will be done in OSPF on the IP range of 10.1.1.0 to 2.3. That is, routing will be done if one of the router's interfaces carries the IP 10.1.1.1 or the IP 10.1.1.2, because 0.0 is the network address and 0.3 is the broadcast address. We will now check the IP carried by the Ethernet interface 030 with the command show IP interface Ethernet 0300. Note that the IP associated with it, 10.1.1.10, is not part of the OSPF IP range. The one that goes from 10.1.1.0 to 0.3. That's why router 1 can't establish an OSPF neighbor relationship with router 4. To confirm, we run a show routing config. You can see exactly the line that is causing the problem. The line network 10.1.1.0 with the mask inverted in 3 times 0.3. To rectify this, you have to put an IP range that includes the 2 IPs of the link between router 1 and router 4. That is to say, the IPs 0.10 and 0.9. But first of all, the wrong line must be removed. To do this, you connect in the OSPF configuration with an OSPF 100 router, and we delete the line network 10.1.1.0 3 times 0.3 area 0 with a no in front of it. And we can now put the correct configuration on it by making it a network 10.1.1.8 3 times 0.3 area 0. That way, the IP range will go from 0.82 and 11. You can see the adjacency of the link between routers 1 and 4 rising in the logs. Now, if we go back to router 1 and we do an IP route show of the loopback 0 of router 4, we can see that the network is well known to the OSPF, which carries the ID 100. Let's move on to the problem of router 5. From router 1, we will check its routing table with a show IP route. Here too, it lacks the loopback network of router 5. 192.168.5.0. Onlance on show IP OSPF neighbor. Router 1 does not see router 5 in its OSPF neighborhood. Show CDP neighbor. On the CDP side, no problem. We will now ping the Ethernet port at the other end of the link to router 5. It works well. So, since there are no problems on router, we will move on to router 5 by starting by checking its routing table with a show IP protocols. In the output of this command, we see that the Ethernet interface 0 to 20 is declared passive. This would explain why router 1 does not see the OSPF network of router 5. We'll confirm this with show running config. The problem being well divided, we would have to remove the line of the passive interface on the configuration of the OSPF 100. We connect to the router configuration with an OSPF 100 router, and we delete the line that is causing the problem with a no passive Ethernet interface bore 20. We can see in the logs that the OSPF adjacency goes up well. All we have to do is check that the loopback of router 5 is in the routing table of router 1 with an IP route 192.168.5.0. Show made on the latter. Everything is perfect. Now let's move on to router 6. With a show IP route, we also notice that its loopback is not in the routing table of router 1. Let's check its OSPF neighbors with a show IP OSPF neighbor. So there, for router 6, as it already sees it as its OSPF neighbor, we will go directly to this one and run a show IP protocols on it. It shows that router 6 only routes the network in 10.3 times 0. It doesn't route its loopback interface. This is why router 1 does not see this loopback, but does see router 6 as an OSPF neighbor. Let's see what you should do with a show running config on the configuration side. We would simply have to add the network of its loopback in the OSPF configuration, which carries the ID 100. To start, we make an OSPF 100 router, and we add the missing network with a network 192.168.6.0 3 times 0.255 area 0. All that's left to do is check on router 1 by giving it an IP route show 192.68.6.0. The network has been successfully added to the routing table because an entry exists. The last problem is on router 7, which is different from the others because there is IPv6, and so it runs OSPF in version 3. If we start by showing it the OSPF neighbors in IPv6 of router, with the command show IPv6 OSPF neighbor, we can see that it has no neighbors in OSPF v3. We continue with a show CDP neighbor. Router 7 is well regarded by the CDP protocol, and if we try a pinging of the IPv6 interface, which is at the end, well, ping works fine. We can now go directly to router 7 with a show IPv6 protocols. Here, there is no IPv6 routing configuration. So, let's check if it's good at least. Activate it on the router with the command show running config include IPv6 unicast-routing. We realize that IPv6 routing is not activated. We're going to need to fully configure IPv6 routing. First, we start by activating it with the command IPv6 unicast-routing. Then we will create the OSPF routing of IPv6 with the identifier 100 and put a router ID in 3 times 0.7 to follow the same nomenclature of the other routers. We give it an IPv6 router OSPF 100 followed by a router ID 3 times 0.7. So a small particularity of IPv6 is that instead of adding the networks in the OSPF routing configuration, here you have to tag the interfaces that will participate in this exchange. So we connect on port 02E0 and we give it an IPv6 OSPF 100 area 0. And we do the same on Loopback 0. All we have to do is check on router 1 with the command show IPv6 OSPF neighbor. This time, it does have a neighbor OSPF IPv6, which is identified by the ID 3 times 0.7. And there you have it. The practical work on the OSPF is finally over. I'll see you in the next episode of the training.